Bismillahirrahmanirrahim. This is the we have already discussed two lectures, I think. But now we are starting from first lecture. We are uh, going to deliver previous lecture. So this is the first lecture. As you know that you have already uh, taken two classes, addition reaction. First topic, addition reaction. And there are addition reactions, and this is the course outline. Addition reactions electrophiles and nucleophiles, electrophilic addition to carbon double bond carbon, electrophilic addition of hydrogen halides to carbon double bond carbon, their mechanism. So this is the unit 1 or lecture 1. In the first lecture, we will cover these topics. And this is the second unit or second lecture, electrophilic addition of hydrogen halide to carbon double bond carbon, their stereochemistry, Marconi through reduced activity. This will be the third lecture, anti-Marconi tool and activities, or the fourth lecture, electrophilic addition of halogens to carbon double bond carbon, their mechanism, stereochemistry, unsaturation test, and the next lecture will be stereospecific reaction. So now this is the first lecture. This is our course outline, and this is the first lecture, organic chemistry 2, addition reactions. The first topic, addition reaction. We will cover two or three topics, addition reaction, enolate anion and heterocyclic compound. The first topic is addition reaction. The course CHEM 562, semester 2 MSc and BS semester 6. So this is the first lecture, the electrophilic addition to carbon double bond carbon. And in this lecture, we will cover these topics: addition reactions, electrophilic and electrophiles and nucleophiles, electrophilic addition to carbon double bond carbon, electrophilic addition of hydrogen halides to carbon double bond carbon, uh, their mechanism. Okay, so now we will start electrophilic. This is the topic. What is addition reaction? We have already discussed addition reactions. Those compounds which have multiple bonds. In organic chemistry, there are two types of compounds, saturated compound and unsaturated compound, cell sugar compound or rare cell sugar compound. Saturated compound are those compounds which have single covalent bond, for example, alkene. And unsaturated compounds are those compounds which have multiple bonds. Multiple bond means double bonds or triple bonds. So double and triple bond, if present, so they have tendency of addition reaction. The molecule can be added by breaking the double bond or triple bond. So they are unsaturated compounds. For example, alkene and alkyne. These are the examples. Carbonyl compound, C double bond O. This is the double bond. But the most usual example is alkene and alkyne. They are unsaturated compounds. So that's why the carbonyl compound, because the carbonyl compound, the double bond is present in the functional group. The carbonyl group is the functional group. So usually uh, we say unsaturated compounds or to alkene and alkyne. They are unsaturated compounds. The carbonyl compounds are not called unsaturated compounds. But alkene and alkyne, double bond carbon, carbon triple bond carbon, if they are present, so they are called unsaturated compounds. So alkene and alkyne, they are the example of unsaturated compounds. In अस्सलाम वालेकुम। जी जी बोलिए। अच्छा चलो ठीक ठीक है। So we are talking about addition reaction. Okay. The addition reactions, we are talking about addition reactions. Okay. Addition reactions, unsaturated compound and saturated compound. There are two types of compound, the double bond and triple bond. We perform unsaturation or saturation test in lab usually. So we check either double bond present or single bond present. This is the test for alkane and alkene. This is not the test for carbonyl compound. तो डबल बॉन्ड अल्कीन है या अल्केन है, तो जो सैचुरेशन टेस्ट हम करते हैं लैब के अंदर, वो जो टेस्ट है वो अल्कीन और अल्कीन के लिए करते हैं। क्या ये डबल बॉन्ड अल्कीन का है या सिंगल बॉन्ड अल्केन का है। ठीक है। अच्छा, अब इसमें हम बात कर रहे थे एडिशन रिएक्शन। तो अब क्योंकि हम ये बात कर रहे हैं कि जो डबल बॉन्ड इज प्रेजेंट, डबल बॉन्ड भी हो सकता है, ट्रिपल बॉन्ड भी हो सकता है, तो दे आर अनसैचुरेटेड कंपाउंड, so they give addition reaction. For example, the double bond, this is the example of alkene. Alkene, the hydrogen will be added and the single bond, the double bond will be broken. The double bond means this is a single, one bond is sigma bond, the second bond is pi bond. The pi bond is weaker than sigma bond. The pi bond will be broken and two sigma bonds are formed, CH, CH. So another example, alkyne, triple bond is present. If hydrogen molecule is added, one sigma bond and two pi bonds. The two pi bonds, one pi bond will be broken and hydrogen molecule will be added. In the another step, if the reaction will be further proceed if you will not control. The another pi bond will be broken and another hydrogen molecule will be added. So these are the two examples of addition reaction. In the same way, the carbonyl compound, this double bond, this is not the unsaturated compound, but this is the carbonyl compound. It has double bond. It can have addition reaction. It have tendency to proceed addition reaction. The hydrogen cyanide molecule is added in this double bond, and the double bond, the pi bond will be broken and two sigma bonds are formed. This is called cyanohydrin. So these are the examples of addition reaction. The carbonyl as well as unsaturated compounds, they give addition reactions. Now the concept of electrophile and nucleophile should be clear. What are electrophile? It may be one atom or group of atoms. For example, oxygen, it has negative charge. Okay. OH minus, it has negative charge. So OH minus, it is the group of atom, and oxygen only one atom, Cl minus only one atom. So it consists of one atom or group of atom, more than one atom. So electrophile and nucleophile uh, may consist of one atom or group of atom. So what are electrophiles? An atom or group which has tendency to accept or search electron pair is called electrophile. So electrophile, the characteristic of electrophile, accept electron pair or search electron pair. It means it is electron deficient. It it want to take electron pair. It is electron deficient. So what are electrophile? It may have positive charge. The positive charge is showing electron deficiency. Cl plus, R plus, NO2 plus, they are electrophile. Another example, it may have polar double bond. Polar double bond, for example, this is C double bond O. This is highly electronegative. Oxygen has high electronegativity. So that's why due to high electronegativity of oxygen, this carbon uh, uh, is electropositive, electron deficient. It has partially positive charge. So this carbon is electrophilic in nature, electron deficient. So carbonyl carbon, electrophilic in nature. This carbonyl carbon of ketone, it is also electrophilic in nature. The third one example, it may have vacant orbitals. For example, aluminum chloride, the aluminum has d orbital, which is the d orbitals are vacant. Uh, and the iron also have d orbital, and the d orbital are not filled. So they are vacant orbitals. They are electrophilic in nature. What is the concept of nucleophile? A substance which surge nucleus or tendency to donate electron pair is called nucleophile. Surge nucleus means positive charge or tendency to donate electron pair. It means it is electron rich. It is electron rich. So it has tendency to donate electron pair. So what are the example? It may have negative charge. But this negative charge is showing they have electron pair. They have tendency, they are electron rich. They have tendency to electron pair. So Cl minus, Cn minus, Br minus, they are the example of nucleophile. It may have lone pair of electron, not negative charge, but lone pair of electron. This nitrogen, the nitrogen form three bond. So the nitrogen has three bond pair with hydrogen and one lone pair. This lone pair belongs to only nitrogen. So this is the presence of lone pair. It has tendency to share with another atom. So it is the property of nitrogen only. So this is the due to presence of this lone pair, it acts as nucleophile. Similarly, in water, oxygen has two lone pair. So the presence of two lone pair is showing that it is nucleophile. It may have non-polar double bond of carbons. This carbon, non-polar double bond, this uh, pi bond is showing nucleophilic in nature. Similarly, in aromatic system, in benzene, the pi electron density is showing the nucleophilic character. What are, so this is the concept of electrophile and nucleophile and organic compounds. They perform reaction on the basis of nucleophile and electrophile. So ionic reactions are occurred in organic chemistry, in organic compounds, but the ionic reaction means not ions, positive ion and negative ion. Here the concept is used electrophile and nucleophile. So electrophilic addition to carbon double bond carbon. Electrophilic addition to carbon double bond carbon. This carbon double bond carbon we have already discussed. This pi bond is showing that it is nucleophilic in nature. So this is nucleophile. It means the electrophile will react with another electrophile, and the electrophile will be added. Alkenes generally give electrophilic addition reactions. Generally, electrophilic addition reaction. For example, this carbon double bond carbon, and this is the molecule AB. The one atom is A, another atom is B, and this alkene, this molecule is added. The pi bond will be broken, and two sigma bonds are formed. So this is the additive product, addition product. And number of example, alkene, because it has double bond, so usually it gives various type of addition reactions. Hydrogen in presence of palladium, transition metal catalyst. Hydrogen will be added. The chlorine in presence of alumina, Al2O3. Alumina is the catalyst. The chlorine is added. HCl, halogen acids, HCl, HBr, HI, they will be added, and alkyl halide will be obtained. Sulfuric acid, in presence of sulfuric acid, alkyl hydrogen sulfate. One side hydrogen is added and the sulfonic group is added on another side. So alkyl hydrogen sulfate. Water molecule in presence of sulfuric acid, the aqueous solution, a strong aqueous solution in little amount of sulfuric acid as a catalyst, the hydration, the alcohol will be obtained. So various type of addition reactions you will observe in case of alkene. Why addition reactions in alkene? Why addition occurs in alkene? क्यों होते हैं addition reactions? The reason, two sigma bonds are formed by cleavage of one sigma bond and one pi bond. This is the first reason. The sigma bonds बन रहे हैं और sigma bond stable होते हैं. एक sigma bond और एक pi bond टूट रहा है. Pi bond इतना stable नहीं होता. Sigma bond ज़्यादा stable होते हैं. The molecules is going towards stability. So this is the alkene, one pi bond is broken, and XY molecule, the sigma bond is broken, the two bonds are broken, pi bond and sigma bond, and two bonds are formed, CX, one sigma bond, and CY, another sigma bond. The two sigma bonds are formed. So the bond एनर्जी जो एनर्जी चाहिए वो कम है, जो एनर्जी रिलीज हो रही है वो ज्यादा है. द बॉन्ड एनर्जी रिलीज इज हायर एज कंपेयर टू बॉन्ड एनर्जी रिक्वायर्ड. सिग्मा बॉन्ड बन रहा है, ज्यादा एनर्जी रिलीज हो रही है दोनों जगह, और जो एनर्जी चाहिए वो ज्यादा. तो यहाँ एनर्जी ज्यादा रिलीज होती है, स्टेबिलिटी की तरफ चला जाता है कंपाउंड. So this is the two sigma bonds are formed. This is the first reason. The second is pi bond is particularly searched इलेक्ट्रॉन सीकिंग रिएजेंट्स. पाई बॉन्ड किसको सर्च कर रहा है? ऐसा रिएजेंट जो इलेक्ट्रॉन को तलाश करता है, यानी इलेक्ट्रोफाइल को सर्च कर रहा है. इलेक्ट्रॉन सीकिंग रिएजेंट यानी इलेक्ट्रॉन जो डेफिशिएंट है, इलेक्ट्रोफिलिक इन नेचर है, तो द पाई बॉन्ड सर्चिंग. सो पाई बॉन्ड सर्च करने में लगा होते हैं अनटिल अनलेस के उसमें एडिशन हो जाए. ठीक है, तो ये दोनों कॉन्सेप्ट्स हैं जिसकी वजह से द पाई बॉन्ड इज कन्वर्टेड इनटू सिग्मा बॉन्ड. इलेक्ट्रोफिलिक addition of hydrogen halides to carbon double bond carbon. इलेक्ट्रोफिलिक एडिशन ऑफ हाइड्रोजन हैलाइड्स. अब हम आगे बढ़ते हैं, डबल बॉन्ड पे कैसे रिएक्शन हुआ. अब हम हमारा जो टॉपिक है हाइड्रोजन हैलाइड का डबल बॉन्ड पे रिएक्शन कैसे होता है, उसकी डिटेल हमने पढ़ी थी, वही हम पढ़ रहे हैं. इलेक्ट्रोफिलिक एडिशन ऑफ हाइड्रोजन हैलाइड्स. हैलाइड्स मीन्स क्लोराइड, ब्रोमाइड एंड आयोडाइड टू कार्बन डबल बॉन्ड कार्बन. This is the reaction, very simple reaction. On the paper, X is equal to chloride, bromide and iodide. Simple. On one side, hydrogen is added and another side, X is added. What is the mechanism? The mechanism consists of two steps, step 1 and step 2. Step 1 is slow, step 2 is fast. It means the slow step is the rate determining step. The rate of reaction depend upon the concentration of substrate, alkene, and alkyl halide. The two substances are involved in slow steps. The concentration of alkene and hydrogen acid both are important. So this is the step one, the nucleophile. The alkene act as nucleophile, and this is the hydrogen halide. This nucleophilic pi electrons, nucleophilic character, the pi electron attack. Nucleophile always attack on electrophile. The pi electron attack on this surge electrophile, and this H is the electrophilic in nature. The pi electron surge electrophile, and electrophile is H plus. So pi electron attack on this electrophile, high H plus. In result, the bond is broken, and the pi bond is broken, and this sigma bond is broken, and in you will get this sigma bond is formed, and this is the carbonium ion, and this is the leaving group. Halide is the leaving group, or leaving nucleophile, leaving group, halide. This is sp2 hybridized, and another carbon is also sp2 hybridized, but after completing the step 1, this carbon is sp3 hybridized, and this carbon uh, retain sp2 hybridized, planar. In step, this is the carbonium ion. The carbonium ion is the intermediate. Intermediate means it is exist, and you can isolate, you can you can imagine. So this is you in short you can say it is the product, intermediate product. So it exists. So this is the carbonium ion. The stability of carbonium ion depends on the nature of carbonium ion. You know that the tertiary carbonium ion are more stable as compared to secondary carbonium ion, and the secondary carbonium ion are more stable than primary carbonium ion, and the primary carbonium ion are more stable than methyl. So the existence of carbonium ions depends upon the stability, the nature, the structure of carbonium ion. In step 2, the carbonium ion, the nucleophile, the one electrophile, the first electrophile is attached, so that's why it is electrophilic addition. In the second step, the leaving nucleophile will be attached with this electrophilic carbon. Halide will make the bond with this carbon. So we will obtain alkyl halide. And now the both carbons are sp3 hybridized. So this is the complete addition reaction. What is the reactivity of HX towards carbon double bond carbon? Sometime HX dissolve in a solvent. Acetic acid we use as a solvent, and HX will be dissolved in this solvent, or dichloromethane. The both solvent can be used as a solvent for the uh, solubility of HX, or by bubbling the gases. Sometimes we use in HCl, HBrHI in their gaseous state. So the gases set directly to the alkene, and alkene using itself as a solvent. Alkene solvent खुद ही एक लिक्विड है, उसमें हम डायरेक्ट गैस डिजॉल्व कर लेते हैं, वो भी हो जाता है। और दूसरा ये है कि हम पहले उस गैस को सॉल्वेंट में डिजॉल्व कर देते हैं, डाइक्लोरोमीथेन और एसिटिक एसिड, फिर उस सॉल्यूशन को हम लेके अल्कीन के साथ कंबाइन करते हैं। तो देयर आर टू वेज, बोथ आर पॉसिबल। अच्छा, अब what is the difference among the reactivity of HX towards carbon double bond carbon? This is HCl, and HCl react in presence of alumina and silica, both are catalysts. HBr in presence of alumina and silica, both are catalysts. And HI This is a fast reaction. There is no need of any catalyst. So reactivity increase. HI is more reactive as compared to HBr, and HBr is more reactive than HCl, and HCl is more reactive than HF. Why HF is unreactive? The HF is too much reactive. Uh, it give exclusion. So it is not react uh, successfully with the alkene and form the product. So HI is successful, gives a successful reaction. It is more reactive, and in presence of HBr and HCl, we require catalyst. You know that HI is the strongest acid as compared to HBr and HCl. What is the reason? Because the bond H और I का साइज बहुत बड़ा है, H का साइज बहुत छोटा है, इस बॉन्ड को ब्रेक करना आसान है। एसिड कौन से स्ट्रॉन्ग होते हैं? जो इजीली H प्लस आइन देते हैं। H आइन क्योंकि इजीली H प्लस आइन देता है, इजीली आयोनाइज हो जाता है, इट इज द स्ट्रॉन्गेस्ट एसिड among these halogen acids. So now we end the lecture. Any question if you want to ask? Yes. जी कोई सवाल आप लोग करना चाहें? जी मैंने आपको राइट्स दे दी हैं अनम्यूट होने के। कोई सवाल करना चाहते हैं तो आप सवाल कर सकते हैं। जी अगर कोई सवाल नहीं है तो हम एंड कर लेते हैं। कोई सवाल है तो यू कैन रेज द हैंड। जी नाम तो लिख दिए ना आप लोगों ने अपने चैट बॉक्स के अंदर?
यस सर।
आवाज आ रही है साफ आप लोगों को?
सर आवाज आज की पूरे लेक्चर में बहुत स्लो रही है, बहुत मुश्किल से सुनना पड़ रहा है।
अच्छा चलो देख लेते हैं क्योंकि समझते हैं ऑनलाइन में ये प्रॉब्लम होता है, कभी माइक का
सर
मसला।
माइक शायद आपका दूर था मेरे ख्याल से।
अच्छा चलो अब तो
माइक
बहुत
थोड़ा
सही हो
दूर
गया, मैंने तो मुंह से ही चिपका लिया माइक।
था। ठीक
अच्छा
है सर।
चलें, कोई सवाल तो नहीं है किसी को? ठीक है
नो सर।
अभी
सर
तो हाँ
एक्सक्यूज मी सर।
बोलिए।
सर कार्बोनाइल कार्बन को अनसैचुरेटेड कार्बन क्यों नहीं कहते हैं?
नहीं कहते हैं, बस नहीं कहते हैं, मर्जी भाई, क्या कर सकते हैं। अब हम ये देखें उसको क्यों नहीं कहते। बात ये है कि एक चीज़ कह सकते हैं, डबल बॉन्ड है ना तो कह भी सकते हैं, लेकिन एक जैसे अल्कीन को हम कहें जी अल्कीन क्यों नहीं कहते, उन्होंने कह दिया भाई ये अल्केन है, ठीक है, और उसको कह दिया जी अल्कीन है। ऐसे उन्होंने कहा भाई जो डबल बॉन्ड है ना अल्कीन और अल्काइन वाले, इनको हम अनसैचुरेटेड बोलेंगे, ठीक है, एक बात कह दी इन्होंने। हालांकि एडिशन रिएक्शन वो भी देते हैं और कार्बोनाइल भी देता है, दोनों देते हैं। अच्छा अब उसकी एक वजह है, सुन रहे हैं आप मेरी बात?
जी सर सुन रहा हूँ।
हाँ अच्छा उसकी एक वजह है। उसकी वजह ये है कि जब आप जब कोई टेस्ट करते हैं ना, जैसे KMnO4 का आप टेस्ट करते हैं, अगर अल्कीन होगा ना उसमें भी एडिशन हो रही है, समझ में आ रही है बात? जब उसमें एडिशन हो रही है तो वो डीकलराइज हो जाता है। अच्छा और जो कार्बोनाइल है उसमें अगर उसमें KMnO4 का सॉल्यूशन ऐड उसमें एडिशन नहीं होती और वो ब्राउन हो जाता है, थोड़ा सा उसमें एक रिएक्शन हो जाता है। तो अल्कीन भी एडिशन रिएक्शन देते हैं, कार्बोनाइल भी देते हैं, लेकिन अल्कीन की एडिशन रिएक्शंस का थोड़ा सा मैकेनिज्म अलग है, और अल्काइन और जो कार्बोनाइल है ना उसका क्या नाम है, कार्बोनाइल का एडिशन अलग है। अल्कीन जो एडिशन देते हैं वो इलेक्ट्रोफिलिक देते हैं, कार्बोनाइल जो देते हैं वो न्यूक्लियोफिलिक देते हैं। फर्क उनका मैकेनिज्म जरा अलग होता है, इनका मैकेनिज्म अलग होता है। और वो जो हम सैचुरेशन अनसैचुरेशन टेस्ट करते हैं वो अनसैचुरेशन टेस्ट भी अल्कीन वाले दे देते हैं, कार्बोनाइल नहीं देता। तो उन्होंने एक क्लास बना दी भाई ये अनसैचुरेशन नहीं है, अनसैचुरेशन हम मानेंगे डबल बॉन्ड और ट्रिपल बॉन्ड अल्कीन और अल्काइन वाले, ठीक है ना। वो अनसैचुरेशन टेस्ट भी देते हैं, उनका एक मैकेनिज्म है, उनको हमने अल्केन के साथ कंपेयर कर दिया कि वो सैचुरेटेड है या अनसैचुरेटेड है। कार्बोनाइल में डबल बॉन्ड है, एडिशन भी है, लेकिन इसकी एडिशन अलग तरह से है, और इसके वो जो अनसेचुरेशन वाले टेस्ट अल्कीन देता है वो भी नहीं देते। तो इसलिए अनसेचुरेशन हमने माना डबल और ट्रिपल बॉन्ड अल्कीन और अल्काइन को। ठीक है, बात वाजे हो गई।
तो यानी सर अनसैचुरेशन की डेफिनेशन ऑर्गेनिक केमिस्ट्री में हम ये मानेंगे कि कार्बन कार्बन डबल बॉन्ड हो या कार्बन कार्बन ट्रिपल बॉन्ड हो, वो अनसैचुरेशन है।
बिल्कुल, हम ये मानेंगे, यानी हम अल्कीन और अल्काइन को हम एक्सेप्ट करेंगे अनसैचुरेशन पे, डबल और ट्रिपल बॉन्ड। ठीक है ना, कार्बोनाइल को अनसैचुरेशन में काउंट नहीं करते।
ठीक है
ठीक है,
सर।
ओके जी, ठीक है, अल्लाह हाफिज।